Hello and welcome back to Little More Learning. Today we will be discussing about advanced data analysis with Python, and here we will be having an introduction to machine learning. So what is machine learning? You can understand it as a subset of artificial intelligence that enables systems to learn and improve from data without being explicitly programmed. So you can do this by using Python's scikit-learn library, and with the help of this library, we can implement machine learning algorithms for predictive analytics and insights. So, next is types of machine learning. So, at very basic level, there are three types of machine learning. Firstly, is supervised machine learning. In supervised machine learning, the model learns from labeled data. For example, predicting house prices based on features like size and location is a part of supervised learning. Examples include regression and classification. Then comes unsupervised learning, where the model finds patterns in unlabeled data. For example, grouping customers based on purchasing habits. And for unsupervised learning, examples are clustering, firstly. Then we have dimensionality reduction. Lastly, we have reinforcement learning. The model learns by interacting with environment and receiving rewards for correct options or actions. Next, for using our scikit-learn library, we need to follow the initial step of installation of the library. And as similar to the matplotlib and cborn we had did, it is installed using the pip command and pip install scikit-learn. This command will let you install this library into your system and work upon it. Now that is very basic understanding of machine learning and types of machine learning: supervised, unsupervised, and reinforcement. Now we will move toward the Google Colab notebook to just understand the examples. These lines of code helps us predict house prices based on size and number of bedrooms. So this is a type of supervised learning, and here we will be using linear regression. So we prepare the data by selecting features like size and bedroom and the target price. The dataset is split into training, that is 80% of the dataset will be split into training and the 20% will be for testing parts. A linear regression model is trained using the training data. And the model predicts the prices for the test data, and the performance is evaluated using mean squared error or MSE. Here we successfully calculated the mean squared error. Next example is of spam detection, and here we will be using supervised learning, and under that we will use simple classification method. What this code does, that each email is described by the features word count, contains offer, and the target is whether it is spam or not. The model uses logistic regression for binary classification, as we are using 1-0 only for classification of the mail as spam or not spam. Similarly, the model is splitted into training and testing model, and here we are calculating the accuracy of this model, and here we get the accuracy as 1. In this example, we are trying to implement unsupervised learning, and in that we are using clustering. In this example, we group customers based on annual income and spending scores. The customers are represented by their annual income and spending scores for the data. Clustering, how it is done, that it groups customers into 3 clusters based on these features. And the scatter plot shows customers color coded by cluster. Now let's understand some best practices while working with your data. The first thing that you need to do is to understand your data. Understanding your data is a very crucial step to explore and pre-process your data. Next is to use simpler models first. Linear regression and basic classifiers often work well for simple problems. You should never focus on complex models in the very beginning of your learning. You should start with simple models first, then move on to moderate, then to complex ones. And that's it for today's video. In the next video, we will be starting R for data analytics. See you in the next video. Till then, happy learning.